All right, so for just like the do nows that came before this, you're going to describe some similarities and the differences between the polygons or the shapes below. So right now, write at least one similarity and then one difference. Pause it now. All right, so some of the similarities that you're going to see between these two shapes is, first of all, they are both, once again, quadrilaterals. They both have 4 sides and they both have 4 angles that you know are going to add to 360 degrees. Okay, now are these both parallelograms? Well, this is a parallelogram because both pairs of opposite sides are parallel, and this pair is parallel, but these are not parallel. So they are not parallelograms. So this does not belong on the parallelogram family tree. In fact, this shape, as we know the name of it already, is called a trapezoid. So today we're going to learn about the properties of a trapezoid. Now this is one of the only shapes that are not a parallelogram, so it does not completely take over the parallelogram properties. Now that might be helpful because it's a little bit easier to remember these properties. However, you cannot get confused with the properties of parallelograms because this is not a parallelogram. So to discuss the main properties of a trapezoid, first of all, the definition states a trapezoid is a quadrilateral with exactly one pair of opposite parallel sides. Now, one pair of opposite sides are parallel. Not both pairs, only one pair of opposite sides are parallel. Now, these sides that are parallel are known as your bases. Please do not think the bases are just the top and the bottom of this, because if this was this way, then the bases would be the sides. So they are just the parallel sides, not the top and the bottom. So we do know that these two sides are going to be parallel. Okay. The second one is that the leg angles are going to be supplementary. Now, I don't know if the leg angles are the actual term, and I will describe exactly what that means. The legs are going to be these shapes, these sides right here. So we know that these are the bases and the other parts are the legs. Now the angles that form the legs, like this angle and this angle, those are your leg angles. So those two angles together are going to be supplementary. But the other leg has its own leg angles, and these are going to be supplementary as well. Okay, so, and these should make sense because they're same side interior angles of parallel lines when you have those transversals. So you just have to make sure that those angles are going to be supplementary. So for example, if this was 80, then this would be 100. And if this was 120, then this would be 60. Good. Now, that is a trapezoid. That is the only cool thing that a trapezoid provides mathematically. The real important shape of trapezoids is what we call an isosceles trapezoid. An isosceles trapezoid is where the legs are congruent. So we know we have our bases. So we know that the bases are going to be parallel. Okay. And then we know that the legs are going to be congruent to each other. Okay. Now this is in addition to these properties. So you have bases are parallel, you have leg angles are supplementary, now you have the legs are congruent, and when that happens, we know that this whole angle and this whole angle are going to be equal. Those are what we call our base angles. This full angle and this full angle are going to be congruent. Those are going to be our base angles. So our base angles are congruent. We also know that the circled and the square angles are supplementary to each other. which now means that your opposite angles are supplementary. This is almost the opposite of what parallelogram said. Okay. Now, number 4, if you look at the diagonals are not cutting each other in half. This piece and this piece are not equal, okay? But you do know that the diagonals are congruent. Okay, and they don't split each other in half, but they do split in a proportion. And what that basically means to you is that at this point, which is not the midpoint, this top matches up with this top. Let's say this is 5 and this is 5. This bottom matches up with this bottom. Let's say that is 7 and that is 7. And then the diagonals are equal at 12. Okay, so moving on to some of the questions. Okay, so for example number 3, we're given a trapezoid. You are finding the measure of each angle. So the first thing that it's asking me for is, what is the measure of angle A? Okay, well, we know this is an isosceles trapezoid because those leg angles are congruent, which means angle C is 100 and angle D is 100. We then know that their opposite angles are going to be supplementary to each other. So 180 minus 100 is equal to 80 degrees. So angle A and angle B are 80 degrees. Now, in the second part, we were given that KB, which is this halves right, or this piece right here, is 21.9. Okay, it's not near an angle, it's the side. Then we have that FM is 32. This whole thing is 32.7. So now we need to find the length of FB. All right, well, what do we know? We do know that these two pieces are equal to these two pieces, and these two pieces are equal to each other, which means that when I add up the 21.9 plus x, that has to be equal to 32.7. So that 21.9 is piece 1, KB. When I add that to JB, which I don't know yet, that's going to be equal to the whole thing of KJ. And KJ and FM are both 32.7. So what I do here is I subtract 21.9 on each side, and I'm left with that top piece equaling out to 10.8. So this missing piece right here is 10.8, which would be the same measure as FB. Okay? So now, doing it again, now a little bit harder, is going to be, so in example number 4, we're given just a trapezoid. We do not know that it's an isosceles trapezoid yet because we are not given that those two sides are congruent. But what we do know is that we are given S and we are given P. So what value of A would make these two angles equal to each other? So that is what we are trying to figure out. We're trying to figure out how, or what does A need to be in order to get these to be equal in order to make this an isosceles trapezoid. So the first thing we're going to do is subtract A on each side. So here we're left with A minus 54 is equal to 27 because these A's had canceled out. Then we bring the 54 over to the other side to get A is equal to 81. So when A is 81, these two angles would be equal, making that an isosceles trapezoid. Now for this next one, in order for this to be an isosceles trapezoid, we need to know that the diagonals are congruent. So here we're trying to prove that base angles are congruent, and here we're trying to prove that the diagonals are congruent. If the diagonals are congruent, then this is going to be an isosceles trapezoid. So first you have that 9x minus 2, then you have that 12x minus 11, and now you got to solve for x. I bring that minus 9x over. So you're left with negative 2, 3x minus 11. Add 11 to each side to get 9 is equal to 3x. Then I divide both sides by 3 to get x is equal to 3. Okay? So here I'm only looking for that x is equal to 3. I do not need to plug it in because it just says to find the value of x that would make this an isosceles trapezoid. Good. Now there's one more thing we need to learn about isosceles trapezoids, or just any trapezoid, and that is called the midsegment of a trapezoid. The midsegment of a trapezoid is a segment connecting the midpoints of the legs. Now, we had a midsegment of a triangle that connected the midpoint of two sides. Now, if x and y were the midpoints of these two lines, the midsegment would connect them. Now, what is so important about the midsegment theorem? Well, first of all, it says that the midsegment is parallel to both bases. So if these are parallel, then so is that, forming two trapezoids in one. And then the midsegment is equal to the average of the bases, which basically means the midsegment is equal to base 1 plus base 2 all divided by 2. So how does this work? Well, here I'm talking about the sides, and I'm going to put an X here. I'm actually going to start with part B because B will be a little bit easier to understand. I'm looking for EF. So what do I need to know? Well, I know that when I add the two bases together, the 13.5 plus the 8, and then I divide it by 2, that is going to be equal to the midsegment. So now, if I was to put this x over 1 and cross multiply, I could do that. Or 13.5 plus 8 is 21.5. And 21.5 divided by 2 is 10.75, or 10.25. So this number is 10.25, which is directly between 8 and 13.5. Now to do that same thing with this question, we know that the midsegment is 16.5, which is equal to base 1, which is x, plus base 2, which is 25, all over 2. So now if I put this over 1 and cross multiply, I get x plus 25 is equal to 33. And then when I subtract 25 on each side, x is equal to 8. Okay. Now the trick here, there's also a small trick here. If I look here, the difference between these two values is 8.5, which is the same here. So if I can tell the difference between two, I can just continue it on the other side. And then here I just have to add it up and divide by 2. So those are the little tricks. This is the midsegment of a trapezoid. So right now you are going to complete your daily work and then turn it in.